In this video, we'll cover Firestore security rules with written tests. Hi guys, this is Dane from FalseStacks and welcome back to episode 4 of the Firebase series. Today we will tackle the Firestore security rules to make sure that our database is secure and not open to any attacks or malicious activity. In addition to writing the rules and learning how they work, we'll also set up some Jest JavaScript tests that will test our rules for us. Firebase has a simulator that you can run locally, which will allow you to test whatever you are putting up in your cloud on your local machine as well. Let's start by setting up our Firestore simulator. You can open up the PowerShell command window and then type in Firebase space setup : emulators : Firestore. When you run this command, you'll see that it will download a jar file which contains the local Firestore emulator. To test out that this works, we will start up the emulator by running Firebase emulators : start and then provide the option only and then supply the word Firestore at the end of that. If you execute this command, you should see a message indicating that all emulators are started. It is now safe to connect. Next up, we can move on to the project setup. What I have in this folder is the code from the previous tutorial, and I will move all of the code into a new folder called mobile. Then I will make sure that the git ignore file is on the outside of the mobile folder and then create another folder called Firebase. This will be the project that will pull down all of the Firebase project definitions, and we will set up our Firestore rules as well as the tests for those rules. You can open up the Visual Studio Code editor and drag in the Firebase folder. Once we're in that folder, we can open up the terminal and type in Firebase init Firestore. This will create a new project focused on Firestore by pulling in the Firestore rules. You can proceed by saying yes and then selecting choose an existing project. We'll select the compound project that we created in the first episode, and you can leave the Firestore rules names as the default value that they suggest to you. Once that's done, you'll see a few files. The Firebase RC file will have the name of the project we are talking to. We'll have another git ignore file, and then we'll have the firebase.json, which will describe the rules and the indexes for the Firestore project. And then we'll have the Firebase indexes.json, which has nothing in it at the moment. And lastly, we'll have the Firestore rules. Let's cover the way the Firestore rules work. To secure your database for Firestore, you have to provide certain rules. We basically have two large rules, which is read and write, and those can be broken down into a more granular level. For the read rule, it is made up of two different rules. The one is get, which applies to a single document read request. The other one is list, which applies to queries and collection read requests. Then for the write rules, it can be broken down into three smaller rules. The first one is create, which applies to creating a non-existing document in the database. The second rule is update, which applies to writing or overwriting existing values inside an existing document. And the last one is delete, which applies to the removal of a document from the database. The way we apply rules in Firestore is by using the allow keyword. We identify which operations are allowed and then give a condition which has to be true for that operation to be allowed. If there's no rule defined, it will be allowed, so you have to make sure that you have an encompassing rule and then specific rules for certain collections. To accurately create a rule set for your database, you have to know what exactly you want to do. So to keep this tutorial as short as possible, we will cover three specific rule sets. For this application, the creator of a post can delete a post, then only the creator of a post may edit it, and then an admin can also delete a user's post. To start off, we'll create the all-encompassing rule that I spoke about, which locks down our database completely. You can remove the body of the current match document **, and we'll set the allow read if false, meaning that no reads are allowed for any of the documents, and the same we'll do for the write by setting it to false. This locks down the database to a read and a write to the random collections that we might not have defined some rules for. To test out if this actually works, we'll set up our unit testing using Jest and JavaScript. This is something that I learned from the Angular Firebase website a while back to apply to my own Firestore projects. The Angular Firebase website has been changed into fireship.io that's run by Jeff Delaney. If you have any Firebase queries about literally anything, you should go over to fireship.io and go through the videos. The tutorial will look exactly like this because I'm not very skilled in JavaScript, so I'm just going to be using exactly what Jeff did and then transfer that over to us for our project. We'll start off by initializing the npm project. Once that's done, we'll install the @firebase/testing module, and when that is complete, we will install the Jest module. Once that is all set up, we can start with the implementation of our tests. The first thing I'll do is create a new folder in the root folder of the Firebase project called spec, and inside the spec folder we'll create a new file called helpers.js. To give some context to the helpers we are about to create, the Firebase database requires you to create a new project and then load your Firestore rules, then add your mock data, and then add your user authentication if you have one into every test you are going to do. And to avoid our test being 20 lines long, we'll create a helper function called setup, which will do this for us and provide the reference back to us of the database linked to our Firestore project. So the first thing we'll do is require the Firebase testing module as Firebase. And then to load up our Firestore rules from the local Firestore rules file, we'll require the fs module. Then we can add on to the exports a new function called setup, which will be an async function that takes in two parameters. The first is auth and the second one is our data. This will be the authentication object required by Firebase, as well as mock data for documents that we want to pre-write before we run our rules tests. Then we'll create a new project ID constant and we'll give it the value of rules spec, and at the end of that value we'll supply the date now value, which will be printed out as a string. This will keep it unique for every test that we run. Next up, we will initialize the Firebase test app by calling initialize test app on Firebase. We'll pass in the project ID as well as the auth object into the initialize call. Then after initializing our app, we can now get a reference to the Firestore database and store it in a constant called db. This is the only difference compared to Jeff's tutorial in terms of the testing setup. We are loading in the Firestore rules and using a Firestore test rules file, which will allow writes for everything before we start writing our mock data. This came up because I had a problem when writing my rules into the database. It was all being denied by default and I still don't exactly know why. Then after loading the Firestore test.rules file, which we still have to create, we will write our mock documents into the database. We'll start off by checking if any data has been supplied. And if there has been data supplied, we will loop through all the keys in the data. We will then get a reference to the document for that specific key. Then we will await and set the data for that document equal to the data provided by the key indexing into that data object. Just to make it more clear how we will supply the mock data, the fact that we're using the key directly means that the key for any of the objects should point directly to a document, meaning it shouldn't be a path that ends in a collection. Then after having written our Firebase mock data, we can now apply the actual Firestore rules, which will be used in production. We will call the load Firestore rules function provided with the same project ID, and then for the rules we will read up the firestore.rules file and put it in a format of utf.8. And the last thing we want to do, which was the point of all of this, is return the reference to our Firestore database. Go over to the left and copy paste the firestore.rules file and then change the name to firestore-test.rules. Then inside of that rules file, change the false to true so that we can allow writes for everything and reads for everything as well. The next helper function has to do with cleaning up after a test is run. We'll call this function teardown, and it will also be an async function that takes in no parameters. The purpose of this function will be to delete all the Firebase apps that are currently running in the simulated environment as soon as the test has completed running. The way we'll do that is by calling promise.all, which will wait for all the promises internally to finish. We will then index into the Firebase and get all of the apps using the apps function. We'll map all of those apps and we'll call delete on each and every one of them. The final two helpers has to do with the readability of the tests. Since every rule can basically be tested by checking if an operation was allowed or denied, we will add two extension functions called toAllow and toDeny that will check if our promise was allowed within the Firebase testing platform. We will extend the expect call and inside create a new async function called toAllow that takes in a value called test promise. Then we create a new variable called pass and we'll set that to false. Then we'll add a try catch statement, and then in the body of the try we will call assert succeeds on the Firebase library. After that we'll set pass equal to true. The reason that this works is because the assert, when it fails, will throw an error which will appear in the catch part of the try catch. Then we will simply log out the error so that we can see which line of this Firestore security rules is causing our test to fail. Then we will return an object that has the same signature as what the expect function expects. The first value will be a boolean, and then we'll have a named function on there called message. That function will return a string that says expected Firebase operation to be allowed, but it was denied. And as I said, we only have two expectations. It's either a rule is allowed or it's denied. So we'll copy the toAllow function and we'll change it to toDeny. And in the try body, we will change the assert succeeds to assert fails. And for the message at the bottom, we will change the allowed to denied and the denied to allowed. That is all of the setup we require to write compact unit test for our Firestore rules. And now it's finally time to write a test for our first set of rules that we added. Create a new file under the spec folder called collections.spec.js. The first thing we'll do is import the setup and the teardown function from the helpers file. Then we will create a new test suite by using the describe function. For the title of this test suite, we will set it to general safety rules. And then we'll add a bit of lifecycle cleanup. The function is called after each, which takes in a function to execute after each test is complete. We will supply it with an async function and we will await the teardown function as the body. Then we will write our first test. And the first test will be should deny a read to the posts collection. Make sure to mark the function that will be running as async, as I keep on forgetting this throughout the video as well. The first thing we'll do is get the reference to our DB by using the setup function that we created in the helpers file. This will return a Firestore database instance with no authentication since we haven't supplied the auth value. The second thing we'll do is get a reference to the posts collection by calling collection on the database reference. Then we'll add our test asserts and we'll use the expect function call. Inside of the expect function, we will call post ref and call the get function on that reference. We want to check that this function is denied by the Firebase rules. So you'll see that our Firestore emulator is still running. If yours is not running, you should run the Firebase emulator by using the command that I supplied earlier. Once your emulator is running, you can run the jest command by using jest./spec. And as you see, that will run our one test which will pass. Then we can create a second test that will be should deny a right to users even when logged in. For this test, we will call the setup function and supply an auth object with a UID of Dane filled. This means that the Firestore request will now have an authentication object associated with it. Then we'll get a reference to the users collection and store it in a constant called usersref. And then we'll do our assert by calling the expect function. And as the promise that we are checking to be correct, we will call usersRef and try to add a new data object with a value of something. And what we expect from this call is that it is denied. You can run the jest/spec command again. And as I mentioned earlier, I keep forgetting to add the async keyword to the function, so make sure to add that. And when we run this code again, we'll see that we get 2 green ticks with 2 passing tests. Now that we've confirmed that the database is actually locked down, let's look at the rules that we want to add first. We'll add number 1 and 2, which is both the creator of a post can delete or edit it. So we'll start by matching the collection that we want to write the rule for, /posts, and then using post ID as the placement ID holder. Then we'll write the rule that says we want to allow the update and delete if the user owns post. Firebase rules allows you to write functions, and so we'll create a function called userOwnsPost. Inside this function, we will get the data from the resource and check the user ID on that data object. To remove the confusion, the resource is the actual document being requested by the Firebase operation. So if you look at the posts inside the database, you'll see there's a value on it called user ID. The data is that object, so there's a field called user ID on that data. And on the other side of this comparison, we will index into the request object and get the auth data and check the UID of that authorized user. If it is equal, we will return true and indicate that the user owns the post. Head back to the collections.spec.js file and create a new test suite. We will call it post rules. You can copy the after each function since it'll be the same for all the test suites going forward. Then we'll create a new test with a title should allow update when user owns post. Mark the function that will be running as a test as async. So as I showed you earlier, the user ID on the post data has to match the UID on the auth object. So we'll start off by creating a constant value called mock data. The first key value in this mock data will be posts/ID1, and the value of this we will set to an object that contains a property called user ID with the value Dane filled. And then we'll create another document with post ID2, which will have a different user ID set to not filled stacks. The reason for creating 2 documents is to test both if it passes if I own the document and if it fails if I don't own the document. Next up, we will create our mock user and we'll set the UID for this user equal to Dane filled, which will match only the first post's user ID. We can then go ahead and get the database reference by calling the setup helper function that we created. The first thing we pass in is the mock user, and the second thing we pass in is our mock data. Then we can get the posts reference by using db.collection and passing the posts key value. And then for the first expect call, we will get a reference to the document using ID1 as the value, which will point to our first entry in our mock data. We will then call update on this document and pass a new object with any value that you want to, but we'll set it to new value. And for this expect call, we expect it to be allowed by calling the toAllow function. Then you can copy that code and paste it at the bottom. And now pointing to ID2, we will expect this call to be denied. This doesn't count as a unit test because it's 2 tests in one, but it confirms the same functionality, and I don't want to spend too much time showing you the exact same code duplicated with one line changed. So as you see, when we run this, we get a pass, meaning that when a user tries to update a document that they own, it works, and if they try to update a document that they don't own, it is denied. Then for the delete functionality, you can go ahead and copy that test completely and change everything related to update over to the word delete, And then as well for the final function call, we will change it from update to delete and remove the values being passed in. Everything else should stay exactly the same, and if we run the tests now, you'll see that this also passes since the rules were written together and they both should work the same. The last rule I want to focus on is by making sure that an admin can delete a post. You can open up the firestore.rules file, and this will now force us to split the update and the delete rules into two separate rules. We'll start by the update, which will leave the same by saying we can only update if a user owns the post. And now for the delete, we will only allow delete if the user owns the post or user is admin. So under that set of rules, you can create a new function called user_is_admin, which will call on another function called getUserData, and we'll index onto that data object and check the user role to check if it's equal to admin. The user data that I'm referring to there is the documents within the users collection that we set up earlier. As you see, there's a user role, and the user's document ID matches the ID of the user. This means we can use the UID of the request object to get that document data. So create another function called getUserData, which will return the data of a get request. The get request takes in the direct path to a document, and for us that will be our root databases. Then using the built-in variable called database, which points to the identifier of our current database for this rule set. And we'll go to documents/users, and as I showed you, the ID of the document equals to the UID on the request auth object. We will return the data from that document. If that doesn't make sense, I'm sure I explained it clearly and you can just go back and rewatch it, but basically we're getting the document associated with the user ID from the users collection in our database, and then we're checking if that equals to the admin role type. Head back over to the collections.spec.js file and we'll create a new test with a title should allow delete when user is admin. We'll start off again by setting some mock data. This time we need a user object with the same ID as the UID that we'll be supplying as the mock user. So we'll create a document under users/filled_stats and we'll set the user role to admin. Then we'll also create a new document in the posts collection of ID 1, and the user ID will be set to not matching 1. And for the second document, we will create a ID 2 and the user ID will be set to not matching 2. For the mock user, we will create an object with a UID of filled stacks, which will match the user in the mock data above. Then we'll get the reference to our database by calling our awesome setup function. We'll pass in the mock user as well as the mock data. We'll get the reference to the posts collection by using the collection call on the database and passing in the posts key. And then finally we can assert our test. We'll call the expect function. And on the posts ref, we will index into the document ID 1 and we will call the delete function on it. And for the expect itself, we want to check that this is allowed because the user filled_stacks is an admin user. Filled_stacks is always an admin user. I'm just saying. If you run the tests now, you'll see that it all passes. And just another test to test the opposite of this function. We'll copy paste again the current test. We'll change the title of this function to should not allow delete for normal user. And unfortunately, I have to remove my own admin rights at this point and change my user role to a user. And now that exact same request should be denied by the Firebase rule set that we created. Running the tests using jest./spec will now show 6 passing tests. And then just to add a bonus rule, we want to make sure the user can create a post only if they are logged in to our application, meaning that they are authorized. So to spice things up, I'm gonna write the test first so that you can see how a failing test looks, what to look for, and then how to fix that. We'll start off by writing a test call should allow adding a post when logged in. We'll make the function async. Then we'll get the reference to our database by calling the setup function and passing the auth object directly into that function. We'll set the UID equal to user ID. Then we'll get the post's reference by calling the collection function on the database and giving it the post's key. And finally, for the assert of this test, we will call the add function on the post's ref, and we'll give it an object with a key title and a value new post, and we expect that to be allowed. If you run just /spec, you will see that we have one failing test, and it will tell us exactly which line is causing it that's failing. And if you look down in the actual error itself, you will see that it gives you a message that says permission denied, false for create line 8. If you open up the Firestore rules and look at line 8, it tells you that it's failing because of the allow write if false in the overall database lockdown rule. And to override that rule, we will create a new rule that says allow create if logged in. It's time for another function. Create a function called logged in, and the way that we determine if someone is logged in, at least for me, you can do it differently. I will check the request auth and I will see if the UID is not equal to null. Some people only check if the auth object is not equal to null, but I specifically check if the ID is not equal to null. I don't know why, it just feels safer. If you run this code now, we should be able to create a post when the user is logged in. And we can. That's basically it. Now you have a set of rules that you can use to test your Firebase rules and ensure you're not breaking anything while updating your rules. The final thing for us to do is for you to subscribe to my YouTube channel and then also run the command Firebase deploy only Firestore. This is the command that will now take these rules that we have written without its tests and deploy it up to your Firebase project. Once done, you can open up the console and you can view your rules by going to your database and then going to the rules tab. Please make sure to share or subscribe or like or all of them with this video, and make sure to check out the other tutorials within the Firebase series. My name is Dane from Fullstacks, and I will see you guys next week.